Good morning, good afternoon, good evening, whatever the case may be, we are back and better than ever. Today, we are talking about tree diagrams. And here's a tree diagrams. Ever play the game rock, paper, scissors? Here are all the possible events. Yes, showing the winners. Isn't that the coolest thing you've ever seen? We are going to do some cool tree diagrams. A tree diagram is pretty cool when you have to find the probability of compound events because you just follow the tree branches. Things to note. A tree diagram always starts at a single point, and then you list your first couple of events here, and then you branch off and do some more. So let's make some tree diagrams. We'll show you how they work. Carl is out of luck, my friends. He's not having a lot of luck. Number one, he owns a car, and it only starts 80% of the time. Dude, it's called a mechanic. And his motorbike will only start 60% of the time. Dude, motorbike, it's an injury trap. Go to the hospital right now. Why not? Draw a tree diagram to illustrate this situation. All right, so we start, hold the phone, Chuck. We don't want the arrows at the end. We just want plain old line segment. Okay, so we start at a point right here. And there we go. Our first possibilities are that his car will start and that his car will not start, which we will call C naught. Yes? And along the branches of the tree diagram, we list the probabilities. That's what makes this completely and totally awesome. His car will start 80% of the time, or 0.8. And it will not start 20% of the time, or 0.2. Okay? Then, from there, we go to the motorbike. The motorbike, what happens? Well, there's two possibilities. The motorbike will start, or the motorbike will not start. The motorbike will start, or the motorbike will not start. Okay? So both times we'll use M, that the motorbike will start, and not M, that the motorbike will not start. That's a horrible M. Let's redo that. Computer is acting up for some reason. A little bit of a delay. Okay. And then M, and not M not. Okay, and what are the probabilities there? The probability that the motorbike will start is 0.6. which makes that means the probability that it won't start is 0.4. Same thing here. Will start 0.6, 60%. Won't start 0.4, 40%. And there is your spectacular tree diagram. If you want, you can write this out, C and M. C and M naught. C naught and M. C naught and M naught. So what do we have? The car and the motorcycle will start. The car will start, but the motorcycle will not start. The car won't start, but the motorcycle will start, and both of them will not start. So use the tree diagram to determine the chance that both will start. Well, this is the only outcome where they both will start. And here's the beauty of the tree diagram. You follow the branches and you just find the product of the probabilities. 0.8 times 0.6 is equal to 0.48. So there is a 48% chance that both of them will start. Both the motorbike and car will start. How about them apples? What's the probability that the Carl can only use his car? Well, if he can only use his car, that means the car starts and the motorbike will not start. And that occurs only here, car and not M. So I just follow the branches along that path and I multiply the probabilities. 0.8 times 0.4 equals 0.32. So there is a 32% chance that he will be able to use his car and not use his motorbike. Carl, you got to find some better transportation, my friend. I'm just saying. Life's too difficult for you. All right, let's move on with our last example, and we are going to talk about some flowers. Yeah, we got 2 boxes. They each contain 6 petunia plants that are not yet flowering. Box A contains 2 plants that will have purple flowers and 4 plants that will have white flowers. Box B contains 5 plants that will have purple flowers and 1 plant that will have white flowers. A box is selected by tossing a coin. So either box A or box B is chosen, and they have an equal chance of being chosen. And then 1 plant is removed at random from it. Determine the probability that it will have purple flowers. Again, the beauty of the tree diagram makes life so much simpler in my humble opinion. So, right out of the bat, we have 2 choices. Box A, oops, it would be better if I use the pen tool, don't you think? We have box A and we have box B. They have an equal chance of being selected, so that's 1/2. You can use decimals if you want, 0.5, but that's going to get messy for these other ones. You'll see why in a second. And from box A, we are if we randomly select a bulb. Did they say bulb here? Oh, 1 plant, a plant. Okay. And then we will either have, let's see, purple flowers or white flowers. So from box A, it contains 2 plants that will have purple flowers and 4 plants that will have white flowers. So that would be 2 out of 6 for purple and 4 out of 6 for white. Okay, so same thing for B, in that it's either purple or white. Oh, time to put on my name tag. And from box B, what's the probability? It contains 5 plants that will have purple flowers and 1 plant that will have white flowers. So it's 5 out of 6 for the big purple and 1 out of 6 for the big white. Determine the probability that it will have purple flowers. All right, so where does the purple occur? We end up with purple here, and we could end up with purple here. So we just follow these paths. I go from box A to get purple, I go here. So the probability of purple is going to equal 1/2 multiplied by 2/6 plus, how do I get to purple here? Well, I travel along this path, then along this path, so that would be 1/2 times 5/6. So that is going to be kapow, 1/6 plus, any kapows here? I don't see anything, plus 5 out of 12. That's 2 out of 12 plus 5 out of 12. So the chances that we are going to have a purple flower are pretty darn good, ladies and gentlemen. 7 out of 12. So there you have it. There are some good examples of what's happening with the tree diagram and the power of it. So we are going to go out with some In Excess because we are done with this topic. My name is Mr. B, and I am out. Yes, I'm out.